Hello and welcome to another follow-up event of the Endorse conference. I'm very excited about today's webinar, and that's because we often talk about linked open data, but rarely about linked enterprise data. And we hear a lot about FAIR principles, but it's one thing to talk, another to do, and a completely different story when you have to implement and manage your data according to FAIR principles at scale. This is what today's talk is about. We're really lucky to have Dr. Martin Romacker, Principal Scientist in Scientific Social Engineering and Architecture at Roche. He has over 30 years of experience in semantic modeling, and Roche, as you know, is one of the largest biotechnology companies in the world. What I personally didn't know is that it is 126 years old, so it has proven it can overcome serious challenges. Martin, over to you.
Yeah, thanks a lot. Yeah, by the way, last week we had our 125th anniversary party here in Basel, which was quite nice. Yeah, thank you very much for the opportunity to present at this event. And also would like to mention that I'm also a big fan of the semantic work that is done by the EU Publication Office. And we also have, say, a long-standing relationship with the colleagues from the various projects. So also very happy to present at this forum. Just will start to share my screen, and this should be the right one here. Yeah, share. And then kick off the presentation. I've also planned to, if time permits, to give a little bit of a demo of the tools that we have developed in-house, so that we can also show how we practically apply all the work that we have been doing. So presentation from current slide. No, that's not the right one. Here is the start. Is it coming through? Hopefully. Yeah, thanks a lot.
Yes.
Thanks. And I activate the laser pointer. Yeah, as you may know, the entire pharma industry is working on data verification at scale. This is a topic that has become very popular across the entire industry, and it relates to a couple of, say, major strategic moves forward towards digital transformation and also doing a better management of data assets. And at Roche Genentech, we luckily have a huge network of people across all functions in the organization working on verification at scale, but also on semantic technologies that we need to support this. And I would like to start the presentation here with a more generic view on, say, some business aspects of digital transformation, and then really take a very, very deep dive at all the various activities we are having, including also one very nice use case that we have implemented at Roche Genentech, and really demonstrating the value and the power of linked data and being able to leverage semantic technologies to transform our business. So the very first slide is a slide that I like to show a lot. And it's also something that I've taken from a colleague, Rick van Bruggen from Neo4j, because it really shows where we are currently. And usually, when we look into digitization, there are a lot of mega trends around this that drive digitization, like data-driven drug discovery in our case. I think many of you might also have heard about personalized healthcare, where we really try to find the right drug for the right person for the right indication. We're looking into ways to improve enhanced decision making, working on massive data integration in data lakes, and last but not least, we have, of course, all this hype about artificial intelligence and machine learning. And I think there is a strong bias towards putting an emphasis on these mega trends. But what people tend to forget, and where there's a little bit a blind spot, at least in larger parts of the organization, is if you really want to achieve and really want to harness the business value of these various megatrends, you need to have connected and high quality data at the center. This is the prerequisite to make all of these megatrends successful. And when we look into connected data at the center, we're of course thinking about verification at scale, but we also look into data quality, which is an additional dimension to FAIR, which we will not cover too much today. We'll focus mainly on FAIR. And at the heart of this initiative to bring the data together here, we have to apply data standards, and data standards come with various capabilities that I will cover throughout this presentation. It is about terminologies, the way how you can register your metadata, and then you also need to provide dataset models and ontologies or conceptual models to your organization. Looking into, say, our industry, we also talk more and more about data as an asset. So really start to see the value of data, and it's something that we have as a value in our organization. There's a lot of costs which are associated to the production of data, and only few of them are really visible or really consciously being perceived about the managers. It's really, in the first place, all the FTEs that are used to create data assets. Of course, in our specific case, for example, you have to procure material. For example, when you run bioassays, or when you also are performing clinical trials. For bioassay would be something like samples, reagents, compounds, and then of course the entire infrastructure. But looking more from an IT perspective, there is a lot of unplanned and invisible costs, which is related to extract, transform, and load processes, searching and accessing data, data cleansing that we do repeatedly because data quality is not as we expect to support our ambitions in the insights business, data curation that comes then as a part of data cleansing, semantic data integration, and last but not least, the huge IT infrastructure you need to support these unplanned activities. I've just seen a presentation last week at the EMBL EBI where Dave McComb spoke about also the data-driven revolution. There was one interesting number that the amount of money we have to spend on data integration. So this more kind of unplanned invisible costs that are due to a poor data management from the very beginning. These are going up from about 40% to now 60%. So that means a lot of the resources we are having available to create value are really bound in data integration processes that create no value. Another interesting observation, this is a quite funny slide I crafted 2 or 3 years ago. We're looking into a metaphor how we work with data. So on the one hand, we say, okay, data is an asset. So we really think it is something that we need to treat the right way. But if you look into the way how it's really done in the industry, you find it's a little bit ambiguous because we don't treat it as an asset yet. And looking into a metaphor, I found, say, the oil industry. As we're also saying now that data is the new oil of the digital economy. And this was also a quite surprising number to me, is when we are, say, pumping up oil, every year we flare about 150 billion cubic meters of gas, which is just, going away. And these are numbers from 2015, where also the price of gas was way cheaper as these days. But this was already about 70 billion euro of value of all the gas just being flared as a side product of the oil production process. And we have a similar setting in the industry, where we say, actually, we are creating data assets continuously. Everything that we are doing in the entire data management value chain is creating new data assets. But most of these data assets, they just vanish every year due to poor data management, just because you don't find them or people are not aware that they do exist. And this also now comes as a kind of a layer on top, that looking into data verification and also turning our data into assets, we also need a very good, very well designed data governance process on top of it. So in a nutshell, I think the pharma industry, we say that data are an asset, but we still do not treat them as such. And this is also the topic that the team that I belong to and the entire community within Roche Genentech, but also beyond. We're also collaborating a lot with other colleagues, from other pharma. This is what we want to work at. And interestingly, if you look into, say, the way how you typically manage your corporate data assets, also in the balance sheet of every larger company, data are not yet counted. So usually when you do the balance sheet of a larger organization, you have intangible resources and tangible resources that are there that represent the value, and data is not yet there. You might have heard about this very interesting case of United Airlines that during the Corona crisis needed some cash to support the ongoing business. And they sold a part of the frequent flyer program data to an equity fund, and they get $6 billion for this. So this, as you can see, data has a value, but most of the organizations don't call out this value in the balance sheet. So we have costs, we have value, but we also have amortization. And this ideally should help us to really also find good business cases and also being able to calculate the return on investment if we really go into verification at scale. So these are the high-level economic considerations. I will now turn to more concrete work that we have been doing at Roche Genentech, talk about FAIR and the so-called Roche Data Commons. And I think the big move that we are currently doing is that we are going from an application-centric view to an information-centric view. And this is where the so-called Roche Data Commons come into play. This is a 5-layered abstraction that we have built on the way how we manage our data, which starts below with infrastructure. So this is where, say, the physical data assets reside, the files for images, for databases, whatsoever. So then typically on top, this is layer 2, you place a data management layer. This is, for example, where data cataloging happens, where you also assign metadata to your data assets, where you also have workflow languages to transform your data, where you also make your data available for sharing. The most interesting layer is this layer 3 that we have called Harmonized Data Access Point layer. It is an abstraction from layer 2, and it offers services to facilitate searching and accessing data in an information-centric way. So we are organizing this harmonized data access points around data types like adverse events, clinical study, digital biomarker, disposition, expression, flow cytometry, patient sample, you name them. And then based on layer 3 that gives you that makes data findable, accessible, you can then create integrated data sets at layer 4. So you pull out the data, and on layer 5, we are building applications, tools for analytics, visualization tools. So at the end of the day, it is really flipping the coin, because in a typical architecture, you have at the bottom layer, you have the applications, then you implement integration, data transformation layers, and then you build your data products on top of your application. Here it's exactly the other way around. So we have the data as the basic asset at layer 1 and 2. We make them accessible, and then we build the applications on top of the data. So we really try to unlock the data. And as all of you may know, applications go away, data stay. So we can also find more productive ways to preserve the value of our data assets. And here this is where FAIR comes into play at scale. Everything that you can see here going from layer 2 to 5 is semantically held together by reference data services. And reference data services also contain the terminologies, the metadata registry, the dataset models, and the ontologies that we provide. So in essence, what we are working for, and I'm also coming back to this topic later, is to build our systems now in a way fair by design, and also to make sure that when we create new data assets, that the data are born fair. And what's a little bit challenging in the organization is to, also in particular in the IT part, to transform a little bit the thinking around the data that we're having, or all the elements that we use to describe data. Because we need to understand that everything is a resource and has a uniform resource identifier. I now start to use more the term GUPRI, Global Unique Persistent Resolvable Identifier. But when you have a data file sitting on a file system, this is a resource that has a URI. If you're describing a data set, then the data set itself is a resource and has a URI. If you describe the distribution of the data set, then this is a URI. So everything, all the assets that you're having, terminologies, code list elements, all of these things are resources. And then, of course, you need to find ways to manage these resources, where we have built up the capabilities I'm going to share with you in the second part of the presentation. And I'm also making here a strong statement because I do believe that the actual verification has to happen here at layer 2 and 3. So this is where you assign your reference data URIs to the data assets. And this is also how you expose them for access. At layer 4 and 5, you only use the uniform resource identifiers for dereferencing. So having said this, and this is also something that we are aiming at, reducing integration layers and reducing transformation offers. So the vision is between layer 2 and 3 on the one side and layer 4 and 5 on the other side, there is no more transformation needed. So if you're really working with FAIR in the strict sense, you can dramatically reduce the data integration efforts within your organization, which, as I mentioned before, are creating a huge cost block in your organization. And just to give you a kind of a flavor how we have been doing this. So at Roche Genentech, we are having a 5-year program which is called EDIS. It's called Enhanced Data and Insight Sharing, where we try to master the data management value chain, going from planning, acquisition to processing, release, and access of the data, with a primary focus on clinical and study data. The point is here that I'll just grade this out for confidentiality reasons, but at all the different parts that where we are building integration layers, or where we are creating new repositories, we use our reference data already to make our data born fair. So this RTS, this is the system I'm going to show to you. This stands for the Roche Terminology System. We are systematically already injecting all the fairness in the systems at the source. So we don't want to do a kind of a retrospective verification with data cleansing and all these mapping and merging. We put fairness directly into the system, so we try to make our data born fair. And as you can see, along the entire management chain, we already have injected this, and I'm going to show you later on the use case of the Roche Dataset Portal, where we really illustrate how this is working alongside the data management value chain. Another view on the same topic is related to the Roche Data Commons, the architecture. Again, you have this 5 layers that you can see here with the infrastructure, the various data management tools, data catalogs, if you wish, the various harmonized data access points. And here on the left side, you see the reference data services. And what we are doing is, as mentioned before, we are verifying everything here at the source. So the data catalogs already contain fair data. We expose them in a fair way via the harmonized data access points. And then we are able to build the applications like this Dataset Portal or other ones or analytics tools here on top. So this is really a huge transformation of the way how we are doing data management and also providing data infrastructure or doing informatics. So now I want to shift gears and look into a little bit into the FAIR principles themselves and also the capability stack. First of all, I think the idea that we're having is to build a semantic infrastructure of fair data. I think what's sometimes neglected is that you also need fair services and you also need fair applications. But how do we know how fair our applications are that we built here at layer 5? How do we know how fair our services are? As you can see, everything is held together by microservices and APIs, and also how fair our data, which are here at layer 1 and 2. As mentioned before, there are 2 flavors to this. I think one is that when you look into fairness, one is the ability of a scientist or data consumer to find, access, and understand data without presence of data owner. I think that's also a very common theme in, say, the community, that you have to have all the information about data lineage, provenance, minimal information about who created the asset, last modification date. So it's very important that the data are self-explanatory in the way how you present them, how they are being served. The second aspect is possibly more important. It's about the ability for machines to find and use the data in a semantically meaningful way, so that data are machine actionable. Roche Genentech, we're also part of the Pistoia Alliance. The Pistoia Alliance is a pre-competitive consortium that wants to foster collaboration in life sciences R&D in a pre-competitive way, which is very good because we really see fair verification, link data. Even though we work with internal data, this is really an industry, or going into the industry, it is a community topic where we have even shared interest with domains which are not life science. And in order to be able to know how fair your data are, there are the so-called fair maturity indicators that we have collected here as well on the FAIR toolkit, which is a resource that we have built as a part of this pre-competitive collaboration. And I think the fair maturity indicators, the fair metrics, this is very interesting because many people talk really about fair and verification, but I think that the understanding is starting to dilute a little bit, and many things are being called fair which are not really fair. And the fair maturity indicators and the fair metrics really helps us to understand how fair we are. And just looking into a few of them, talking about findability, for example, in FAIR, data and metadata are assigned separate global universal identifiers, which are unique and persistent. And then again, I think we also emphasize here the rich metadata that we use to describe data. And ideally, these metadata should be grounded in shared vocabularies, which are community standards. So if you want to go fair, you don't work in a context-free field. You don't have a greenfield approach. You have to place your resources in a context, and you have to adhere to guiding principles, to a certain fair governance, if you wish, if you want to make your data fair. And the same applies here. That's the third letter here in FAIR, the interoperability, that you use formal, accessible, shared language, where you say on the one hand, it can be, that's the relaxed version here, it can be any kind of structured information, but strict is we use ontologies that have also machine readable formats, and also the data and metadata are described with fair ontologies and resources. So at the end of the day, verification really goes very deep in the way how we are doing data management, data governance, but also IT. And this is, in order to build this idea of an open, private, public infrastructure of fair applications, services, and data, we have actually seen that the key community who is supposed to implement fair, they really don't have a high affinity to understanding what fair is. And the key community, these are the IT people. So IT is a key enabler for verification. Actually, all the data producers, the people who are really generating data assets, they shouldn't even care too much about fair, because we would build our systems fair by design. And this is why we have written this fair architecture playbook, which is a primer for IT architects, business analysts, and software engineers to really make this community aware. What does it mean, for example, to really implement fair at scale? And this again goes very deep. For example, if you want to bring in a new software and you have to go through a vendor selection, how can I ensure, for example, that a software that I acquire for a specific area in regulatory, for clinical trial management, that this system is really able to support fair? And I can only tell you by experience is that most of the systems that you currently encounter, so vendor systems that you can acquire as an industry, most of these systems really don't support fair natively. So you have to do a lot of work on this. And within this FAIR playbook, we also worked, FAIR architecture playbook to be more concise. We also worked on the concept of digital objects. And I think it's very important to understand what digital objects are and how they play into FAIR. So a digital object is any kind of data that exists in a digital modality. But you can also have a digital representation of a physical object or a process. That would also be a digital object. And at the end of the day, there are two different types of digital objects. Some of them are first-class digital objects, as we call them, because they are born digital. Think about an MRI image. You go to the hospital, you have an MRI, and this image is not materialized. It will directly be a digital asset, so a binary object that sits on some file systems. And on the other hand, there are many, many objects in the real world that can never be digital by design. For example, if you take a biospecimen, a blood sample, this is a physical object. But then what you do is you create a digital twin that represents this non-digital object. And typically you do this in so-called registration systems where you register your samples, where you register your clinical trials, where you register your assays, where you register your compounds. And very importantly is you should not confuse a digital digitization with verification. So born digital doesn't mean necessarily that the data are born fair. If you want to be fair, then you have to go to the fair maturity indicators, and you can then also look and how to do it. So fair is not only about that. If I can find something, it doesn't imply that it is fair. I can also find something in the drawer of my desk, or I can also find something on my local drive, on my C drive, on my computer. So fair is really and above all about the how. One part of this FAIR playbook is also about this global, unique, persistent, resolvable identifiers. I don't want to go deep into here because I would also assume you have a certain level of familiarity with it, about global, unique identifiers, persistent and resolvable. One point is which is something which is very difficult is the global uniqueness. So ideally, you should have one digital object representing one asset which exists once in the globe. A good example for this are identifiers for journal articles where you have the DOI that unambiguously across the entire globe identifies a publication. But in our world, it's more difficult. And if you think, for example, about a disease indication, if you think about a drug product, unfortunately, we find many URIs resources for the same object. So I think what's important is that in the ideal state, you have one digital object for one asset, and vice versa. Every asset has exactly one digital object, one identifier. So this is an objective for which we want to, for which we need to converge. So making our knowledge space more tractable and govern it better and align. If you want to scale up FAIR in the organization and apply the principles, you also need to establish some capabilities around FAIR identifier management. One is namespace registration. You also have to look into the policies, how you establish the format and the structure of your global, unique, persistent, resolvable identifiers. You need a way to generate and mint new identifiers in an unambiguous way, of course. And last but not least, you also need a resolution service that when you encounter a resource, that you can also determine what is behind this resource. We also have set up for our information architects guidelines on data and metadata. As you may know, or as you may recall, FAIR requires that we have rich metadata describing our data. And I think there are two different types of metadata coming along with a digital object. The first one, you see it here on the left side, and this is also of one of the recommendations we make in the FAIR architecture playbook. So define the minimal metadata for every digital object, which is, of course, it should have a human readable label. Ideally, it should have a definition, a creation date, who has created the asset, when it was modified, contributor. And as you also see, when we apply this internally, we also apply the FAIR principles. That means we do not create new resources to describe this metadata. We refer to community vocabularies, which are harmonized and standardized across the community, and we apply them. So going FAIR means that you also adhere yourself to the FAIR principles. And the other one is that you can also use metadata to describe more complex objects, like, for example, here, a drug. This would be more semantic relationships, like a drug has a strength, it has a route of administration, a dosage form. It also has some kind of ingredients. So now looking into what you want to achieve, we can take a look at the capability stack. Don't worry, this is a very busy slide here with a lot of text. I'm going to read out the most important parts, but I think the first level of your capability stack, this is really terminology management. And I'm really talking here about the linguistic aspects of managing your data. And again, what is quite nice for managing terminologies, we have standards available like SCOS, COSXL, Similar Knowledge Organization System. And you can also say that a terminology is really a kind of a canonical object where you have an identifier, typically also have an ambiguous, complete preferred label with a textual definition. You also provide synonyms and eventually also cross-references if you want. And here comes the important point. Every concept is represented by a GUPRI, this global unique persistent resolvable identifier, serving as reference. That's a guiding principle. Next level is about metadata, where typically you register your metadata elements, data elements. People also call them differently. They call them variable, field names, properties, attributes. There are some different names used this. And in the metadata registry, you describe them again with rich metadata. Also, you can have synonyms. You can also have cross-references to other metadata registry, as we do also internally. And the set of all these metadata elements then forms a so-called data dictionary or a data catalog, a metadata catalog. You can, when you use metadata, you can also provide more information. So if you use them to describe a table-like structure or data set, you can also determine the value domain. So if it's a data type, string, Boolean, date, or if it's a terminology, for example, if you have unit, for unit, you can have a terminology, and then you can link this in. And then you can also define constraints, type constraints, data collection constraints in this metadata element. And every metadata element, again, is represented by a GUPRI, and also the dataset models are represented by this global unique persistent identifiers. Last level is about conceptual and logical models, also ontologies, if you wish. And for state-of-the-art data information architecture approaches, we have organized our knowledge space into data domains and subdomains, which means that we don't want to build the one overarching complete ontology that covers the entire Roche Gen technology space. We as shown before, also with the harmonized data access points, we are information centric. The information objects define the data domains and the subdomains. And for those, we are building purpose-driven ontologies using classes and properties. Then we can also use these domain ontologies that with these classes and properties to as a blueprint to instantiate knowledge graphs. So every class and property is represented again by a GUPRI, and the same applies here to the logical model or the conceptual model or the ontology, if you wish. And if you visualize this stack now from the bottom to the top, we have the terminology management at the bottom level. Then we build the metadata registry and the dataset modeling capability on top of this. And then we have the conceptual modeling or the ontology modeling, if you wish, above this. And the vision that we are having and that really starting to already work out quite nicely is when you use this reference data here to drive your data management, and then you aggregate your data at the top here in a unified domain model, in a knowledge graph or in a set of knowledge graph, this integration comes more or less for free. So it's really a clean stack from the top to the bottom, from terminologies, metadata into ontologies, conceptual models, filled up with data, and then you join this, or you can join this also on demand. In the commons model, it would be at layer 4, and then you work with almost no transformation or no transformation, as I will show to you in the use case later. This is the tool that we have built in-house that I'm going to demo later. It is called the Roche Terminology Management System. The scope is nowadays broader, but we exactly have these 3 components. And at the terminology level, we have integrated more than 100 productive applications to this terminology management system. At the end of the day, in the UI, just want to spend little time on this because I will show it to you later. We have here a way that we manage so-called master terminologies. We distribute them across the application space. Every application has its own partition, and we are really able to custom tailor the needs for terminologies one-to-one. I'm going to demo this. And as mentioned before, this is how typically a lexical element, a lexical concept, a cost concept looks like. In the terminology management system, you have a preferred label, you have a URI, it belongs to some cost scheme. In this case, it's indication, it has a definition, a set of synonyms with metadata, like, for example, language, the source, provenance. We also have what we call label types, and also lexical types, which come from cost pref label, alt label, hidden label, if you're familiar with cost. Next level, this is here on a different tab in our system. It's about the metadata registry. Here I have an example from the clinical space where we have some variables that are used for data collection in the demographics domain. So if you have a patient, how you would describe him or her, like age unit, then you have also the country, date of birth, some other parameters here. This is just a bag of variables that you can use. And then in a specific application context, you're now able to pick up these variables and to compose them for your specific need. So you don't have to take all of them, you take just the ones that you need. Like here, for example, for the harmonized data access point for subject, we have age and age, the analysis age, country, date of death, BMI, ethnicity, whatsoever. When you use such a variable, you're also able to give the metadata here. For example, the variable name here is country, which has as a value domain an application terminology, which uses the 3-letter ISO codes. It is typically single valued, and it is a required variable for data collection. Next level is about the conceptual model. And some of you might be surprised now and say, okay, why don't these guys use Top-Rate Composer or Protégé? Why do they build this on their own? And the reason is pretty simple. It is governance. So we are building here conceptual models using, again, this kind of tree-like structure. Here, for example, we have a core model for a knowledge graph. So these stars, these are classes. So we have pathways, for example, we have drugs, we have tissue, we have cell, disease. And then we can also add properties to them and then also specify what are the value domains of the properties. Here, I just want to draw your attention to the class genetic variant disease association evidence. So this is, we have a gene variant and a disease, which seem to be associated, and there's some evidence supporting this association. That's all represented here by the class and by the properties, and this then all goes together into the ontology. And the reason why we are doing this internally is governance. Whenever someone wants to build a new model here, then he or she has to pick the classes and the properties from a pre-selected set of properties and classes which are fully governed. And whenever I use, for example, the class drug or the class cell or the class diseases across the various domain, we ensure it will always have the same identifier. So these different models are interoperable by design, the way how we set this up. Of course, we have native support for RDF-OWL, so we can also then take the model here, translate it into a turtle file, and then use also Protégé as a tool. But we would not do the edits in Protégé. We would just use this for a Q&A tool, also running here a classifier, but the actual governance and the actual modeling is happening here at this level. In case you are a little bit closer to IT, this is a typical IT stack where you say manage your different layers of model layers. The conceptual model is where you define the concepts and relationships. Then you have the logical model where you also are a little bit more detailed with data elements, groups, cardinality, data types. And then last but not least, you also have the physical implementation. This is how the data is then implemented in a relational database, in a document store, or wheresoever. And with our capability stack, we are covering all of these different layers with a specific overlap. But this is an integrated framework that really supports everything which is needed to implement fair data repositories and fair applications. And I would also say, looking into information architecture, that it's an interesting side aspect, that building ontologies is really something that is information architecture using RDF-OWL as a language to do information architecture. We also have, of course, tools to visualize the models that we built in our graph, in our interface that you've seen before. Here again, you see the gene variant disease association with the disease that is being one associated element, and the specific variant. And here you have the evidence. Now I can use this ontology here that only contains classes and properties to instantiate a knowledge graph with data. And just to illustrate the power of this approach to you, I give you a small example. So this is the ITO knowledge graph that I've shown before in this box, the black box. And then here you see, for example, an instance of a gene disease association with an associated disease and an associated gene variant and some evidence. At the same time, we also maintain a knowledge graph for our competitor information data, which is the portfolio of other pharma companies with their different drugs, which sit here in the circle for diseases, where you can also get information about the drug class, the phase in development, and whatsoever. And in this specific instance of the example here, I have Parkinson's disease in the focus. And now if I want to know from the ITO knowledge graph context, okay, I found a very interesting gene disease association. Is there any portfolio information about other pharma working on this? That, for example, could be an indicator to look into specific molecules with a specific bioactivity, or to say, okay, this is, for example, a field where we already have mature products, so not worth investing here. This integration here comes as a simple Sparkle query because we are using the same URI for Parkinson's disease in the two graphs. So we don't have to integrate anything. We just have to run a Sparkle query across the two services, and we are done. We can expose the results. This is extremely powerful. It's extremely cost saving. It is time saving, and it really boosts the way how you can generate insights. I also want to briefly touch JSON LD, JSON linked data, and fair APIs. I think this is something which is sometimes neglected in our community, because as you have seen also from the Roche data commons, the APIs really hold the entire architecture together. If you really build data domains, subdomains, you organize everything around fair, then you also need to exchange data in a fair way, which is done through the APIs. And this is a real example from say our environment, where we have and harmonized data, two harmonized data access point, one coming here from development, the other one coming from preclinical research. And this is just a snippet of a JSON output where you have something like study indication, and then you have a label non-small cell lung cancer. In the period study HDAP, you have a label, an attribute label, which is target disease, and here you use the acronym. And then we also have a repository where we register our clinical standards, where you have an attribute which is called therapeutic indication, and then they're using a string carcinoma non-small cell lung. Now, if you want to integrate the data from these three different resources, I'm back to square zero, because I again have to do data transformation with mapping and merging, bringing all of these data together. Why do FAIR APIs help here? So FAIR APIs mainly built on JSON LD. And you can also think of JSON LD as a notation format for RDF. And I'm just giving the example here about non-small cell lung cancer. So at the end of the day, what you're doing is two things. So one is you are giving, say, all of your data with URIs. Like here we have, for example, the identifier of non-small cell lung cancer. Then we have a contributor. We have a couple of broader terms, so parent terms with the identifier. We have a definition. We have a status in the life cycle. Then we have some information about COS6L. In essence, it's something like subject, predicate, object. So this concept has the status active. What we do on top of providing URIs for the data elements is we also give a context. And the context explains the model that is behind, and everything is fair and transparent. So if I want to know what a contributor is, what a broader as a definition is, I can look it up here, definition, and then again, I have here fair resources. So all of my metadata, the attributes in the JSON, are described in a fair way. And this is something that I can immediately serialize as RDF again. Coming back to the example, so now what I can do, if I have here JSON LD APIs and I say, actually, I provide my preferred label here, the non-small cell lung cancer, and all the lexical variants, together with the identifier, which are the same, then I can immediately integrate this. But the same also applies to the metadata here. So in the system, we have recorded that study indication, target disease, and therapeutic indication, in essence, are the same metadata element. So now I can instantaneously say, okay, what is coming out of these three different APIs with the content element non-small cell lung cancer refers to the same attribute and refers to the same data element. And I can immediately federate and merge my data without having any kind of effort here. I'm going to tell you now how we bring this into the business. I think this is also a very important aspect. Then I have a small example, and then I'm also done with a presentation. Thanks for your long breath. I think it's a real dense and long one, but please bear with me for another 10 minutes, and then we can open the Q&A, and I can possibly also in the Q&A demo a little bit the tool. So there are two important parts. One, of course, is architecture. So our reference data services are by themselves fair. So we have everything which you see in the reference data services is an RDF with the models behind it. We are using here GraphDB OntoText as a triple store. We have a Sparkle update API, but when we communicate with our consumers, we don't use Sparkle. That's just for experts here. We use a JSON LD REST API, which has two parts. One is the internal API, which we also use to serve our tools, and the external, which are for data consumers. As I mentioned, we have currently around 110 data consumers accessing our semantic assets. Very interestingly, we also have full versioning and full audit trail. Every atomic change to a concept, to a terminology is recorded. In order to do so, we use a MongoDB where we store JSON LD objects that represent the status of a concept or the status of a terminology. This works extremely nicely. So we can tell you at any point in time what the status of a terminology has been at this point in time, and it really helps you to support the lifecycle management of your terminologies. But also, for example, when you run a data transformation task based on the status of a terminology at a given point in time, then you still have this available, and you can also reproduce and reuse the results. Yeah, and here on top we have a set of tools, the curation client that you have seen before, the browser, the model browser where the screenshot comes from. We have some tooling around this. We have a plugin into G Sheet where you can do mapping of content. We have an R library for our data scientists who don't like Json too much. We have a bot framework that's also very interesting. So we also get automatic updates from resources by which are in RTS by just crawling them. We also have bots for quality checks, consistency checks, transaction checks, which are in the framework, and then we have all these consumers. So that's the technical part for the consumption. And the second part I'm going to show to you, this is possibly the most important part in my experience. It is not sufficient if you offer infrastructure, technology, and content. You really have to help the organization at scale to bring this into the application and into the business. This is why we have this data harmonization service. So we as a team owning all these reference data services, the semantic resources about terminologies, metadata, dataset model, and ontologies, we heavily collaborate with the business to make their applications, to make their data fair. So we offer standardized terminologies, the custom tailored terminologies, the dataset models and ontologies, which are all fully harmonized and fair by design. We also work on the maintenance. That's very important. When applications go live, we don't leave them alone. We constantly, they have new requests. They need new indications, new diseases, new mechanism of actions, new drugs coming in. This is a constant flow that we support. And we also enhance existing standards. Then we also ensure that we have shared semantics. These are the conceptual models that I've shown before. We provide technical support for API integration, debugging. And this fifth topic is very, very close to my heart. It's about data standards and data harmonization, which is really a community topic. It's not early development, research topic. It is not a Roche topic. It is an industry topic, and it's even a community topic. So many of the resources that we can use are coming from the community. Let's take, for example, BFO as an upper level ontology. It's highly relevant to us, and these are all community efforts. So we consider ourselves as a part of an open community, very willing to collaborate, very willing to share, and very willing also to work on shared resources. And then last but not least, we have this toolbox here that are productivity tools that help us to work in a fast way. So now I give you 2 minutes or 2 seconds to breathe, and just to give you this one use case. We have several use cases, but this is really a true fairy tale about verification at scale, which works. And it's pretty amazing. So you also have seen this before in the Roche Data Commons. We have this Dataset Portal, and this Dataset Portal is a data catalog of data catalogs. I think as a huge organization, you will never have one data catalog that describes your data assets. There will always be different one, or even if you're also a distributed organization. So we have data assets, data catalogs for biomarker, clinical data, digital biomarkers, imaging, omics, real-world data sets. And all of them are stored in one source system, in the source systems, but then they are published into the dataset portal. And then they have one point of access to search and view all of these resources. This is the user interface here, where you see these are different dataset providers, a clinical data sharing environment. FireDB, for example, has study data. We also have omics data, clinical data sharing environment. There are also some indication-specific or domain-specific data sets here, like cancer immunotherapy. Also some data assets which are related to clinical trials. And they're coming from multiple sources, and they are published into the system using shared metadata descriptions. And then you have a search capability with using the fair metadata with facets about the data repositories. As I mentioned here, GeneStack, for example, this is omics data. clinical data sharing environment, FireDB again, study data, and then you have facets like file formats, indications, drugs. And all of this is possible because we have a semantic description behind this dataset portal, which is fair by itself. So here you see we are using Vidoko to publish this, and all of these elements here are resources. I can, for example, dereference pharma informatics. I get a URI for this. I can dereference a person and then get the information about a person. In essence, the model itself, the core of the model is using DCAT plus some extensions, and then all the terminologies that are used in this portal are coming out of the central reference data service piece. Now, and this is the point, all the data providers, they have a data contract with the portal that they provide the data, the metadata and the data into this portal using JSON LD. So whatever portal you have here downstream, they publish the same way. And this is how this JSON structure looks like. So you have unique identifiers for the various assets, for the data set, for the dataset version. This is something which is then also DCAT specific. Then you have standard metadata and control terminologies, for example, about the licensing, the sharing policies internally, the data privacy. You describe your distribution, that's DCAT again, and then you have details here about the file format, the digital repository it's coming from, and all of this are resources. And you publish this into the dataset portal without any transformation. It's just read in, nothing to do on this side. And this really is a huge relief based on these data contracts and the prospective verification of all the downstream systems with a fair backend for the dataset portal, helping us to be very, very fast, agile, responsive, and also having a comprehensive overview of all data assets with a single access for the user. And last but not least, that's a kind of a very pleasant side effect of having semantic descriptions. You can also do automatic fair assessment of the content in the dataset portal, where we apply the fair metrics based on some properties and predicates, and then we automatically calculate the fair score for some of the data assets. You just see the test version because I cannot disclose any internal contact, of course. So that's really done automatically. So this is also where I can conclude already, opening up the floor for questions. So we want to have high quality, standardized linked data. And a very important message, I also have to admit, it's extremely difficult to get this through also in our industry with our management. This is the foundation for digitalization and insights generation. If we don't have this, we will lose a lot of time and money on the way to integrate our data assets for any kind of project. Another point which I find very important is, at least in my opinion, if we really take the FAIR principles for serious, this ties us into, say, at least into semantics, using common vocabularies like SCOS, SCOSXL, DCAT, and so on and so forth. I mean, it doesn't mean that everything has to be stored then in a triple store. It only means the logical and the conceptual level should be represented in a fair and in a semantic way. Ideally, of course, using semantic languages like RDF, RDFS, and all. The data integration can come on interoperable domain knowledge graphs. And then we can really build these unified models by just scaling up these domain knowledge graphs into something more aggregated. And this really is becoming a reality. FAIR is about the how and not only about the that. Look, please reconsider the FAIR maturity indicators and try to drive your data landscape, but also application development, having these maturity indicators in your mind. At the end of the day, what we are doing in the data management value chain is we have a new architectural approaches around data and information, and the interoperability of terminologies, metadata, dataset models, and ontologies is key. And at the data management strategy level, I think there's really this urgency to build and integrate semantic capabilities. I think we currently have this strategic window, I think there is a lot of white space still that we need to conquer, but at the end of the day, we want to have this open public-private semantic infrastructure of fair applications, services, and data that you can also eventually, assuming that, for example, a new pandemic comes up, make Roche data available in some consortia in a seamless way. So I think there are new ways of data sharing, data integration that we're working on. And my final statement, last but not least, I think everything is about semantics. I'm really very much in favor of considering semantics in particular when it comes to verification and data quality. I think many times people think too technically about this and they forget about the huge semantic dimension of the work that we have been doing. Yeah, with this, I can possibly pause here, taking questions, and then possibly during the questions, I can also show demo a little bit what we have to really underpin that all of these things are live and reality.
Okay, thank you very much indeed, Martin, for this fascinating presentation, I believe. It gave us a clear view on data verification at scale, semantic backbone, and especially all the efforts you have put on all this at Roche. Quite impressive. I think for all of us, findability, accessibility, interoperability, and reusability of data is key, but it also needs appropriate data governance and, of course, a long-term commitment and strategy. So thank you very much. I've been looking at the chat and it's quite empty. This means you were impressively clear on all levels. But okay, we can leave the floor for immediate questions at this moment. So please, yeah, I see from Reet Sommer that you have a question. Please, the floor is yours.
Hello, I'm Reet Sommer, European Parliament. You said, so thank you very much for the indeed impressive presentation. I think it's really useful for us as well to see a real life case and see where it's actually working. You said something in the beginning that what is challenging in the organization is to transform the thinking, and I think it was about data. So how did you, or well, how are you managing this challenge? How are you kind of, what are the things you do? What do you see? What works? What doesn't? And where do you think what made a difference or is making a difference? Thank you.
I have to say the first answer is it is a fight. It's not a golden path that you just walk along. It is a fight, and it also requires constant hammering. It's not like these things are then going into the brain and will stay there forever. And I think you constantly have to work on internal communication. You constantly have to look into communication plans. You have to do multi-channeling, user group meetings, newsletters, stakeholder involvement, trying to get executives on board, all of this stuff. I also have the impression, that it's. I mean, people really start to embrace these transformations, but I think they still do not really see the implications. I frequently have the impression, for example, that now we are talking about data products and people say data, but they still mean application. It's really something that requires a lot of education, and really understanding how deep this goes is very tough. I mean, if you take a typical software project where people then start to craft a new system that has again a new data model, that has again new variables and everything, they have to understand, no, your work is now in a context. You cannot just craft your metadata elements as you want if you want to be fair, right? You really have to put, say, the effort of doing good data management to the very beginning. And I think this is also where you possibly have the highest return on investment. I think, as I mentioned in the very beginning, this effort that we are spending in this triple-digit billion effort on data integration, there's no value in this. This is just data crunching. And I think what we want to do is to really put this to the very beginning. Also things that come out of data governance frameworks like first time right, zero maintenance, or at least reduced maintenance. I think we are really paralyzing our organizations with transformation work, but we're not changing it, right? And if I had, say, the perfect recipe for you, I would tell it to you. I think we're making progress here, and I think what's also very important is that we really act as a community here. So I also talk to other pharma talk to us, to really make people understand when I have 3 different systems and they represent the data in a different way, and they have different ideas about value domains, about the ranges of, and you want to bring this data together. There is, besides the loss of time and money and effort, there's also a huge loss of information, which is possibly not recoverable. And I think what we are still lacking as a community, besides the report that the European Union made about the cost of not having fair data, is tangible economic data. I think there's nothing like data economics in companies so far that really look into the actual costs of data management. And I mean, if let me put it this way, there's a very nice data value formula coming off the Competence Center for Corporate Data Quality from University of St. Gallen. It said data value is data volume multiplied with data quality multiplied with data usage. And I think, for example, we don't consider if the data that we are producing, are they really being used? If someone is producing this data, if usage creates an incentive, that also makes people sharing data. So having said this, there's still a lot of work ahead of us. The good news is, I think we are no longer in a niche. I think people understand we are part of a data strategy. But honestly, the way that we need to go and the number of people we still need to convince, it's long and the number is huge. I don't have a better message for you here, unfortunately.
I think it's a great message, and it's very realistic, and that is what I also expected. How big is your team working? You said you have a 5 years program running, but I can imagine that we didn't start now in 2018
No.
doing it. It's decades of work on it already, preparing all this.
I mean, I think it was also mentioned by Geertz, is that it is really a long-term strategic investment you have to make here. And possibly you have to separate 2 parts. So one is this reference data services that we are building for the terminologies, the metadata, and then the application into the space. So this 5-year program, that was something that has an emphasis on data management, clinical data sharing, and we were just a part of this. So our mission started before, and also the mission is broader. But this project was really a good test bed to show that these things really work, and that's possibly the other part of the strategy to bring this broad into the business. Don't think big, but start small. Whatever we do, also with the product you're seeing here that I'm sharing, was a very small system that started 5 years ago. We didn't want to do the big bang. We really did first elements, and we constantly brought this into the business and created value. If you can show value 3 years down the road or so, this is too long. Just get people on board and show it. We have a product here that needs a lot of explanations. It's not something that people will just understand. Oh wow, semantic technology is fair, fantastic. You have to explain it. You have to show it. You have to really also demonstrate where are the issues in the data, and I think then it works out quite nicely. And the team, the core team working on this, we are including software development, the rollout into the business, we are a team of 7. Plus, we have some externals helping us.
Thank you.
Okay, thank you, Martin. There are 2 questions in the chat, and then Mihai raised the hand also, so maybe I do them in the logical order. First of all, there is a big applause from Redi to you, Martin, so I can only confirm, big applause. There is a question from Inma on the questions. The datasets providers, are they all English speaking, or In other words, do you have data in other languages like Spanish or French? What would open your portal to a broader audience?
Yeah, that's a very good question. So, I mean, so far, the bulk of the data we are having is English. But of course, if you go more and more into the real-world data space, where we have collaborations across affiliates or countries, we're also getting more and more requests to work with other languages like French, Chinese. But in terms of current implementation, it's not too much that we're having, but it's on the roadmap for this year, and the system itself is built in a multilingual way, so we can support as many languages as you want. But I fully agree. So if you want to increase the range and the depth of the integration, this is certainly something which is on the agenda for this year.
Okay, thank you. There are other questions coming in, but I'll treat the second one from Asma. What approaches, technologies are you using for ontology modeling, evaluation, and validation?
Yeah, as said, so for the ontologies, we are using this self-built tool here, right? And the reason why we have this in-house built tool here is that we fully govern our reference model. So when someone creates a new ontology resource, it's not a greenfield approach where they will have new URIs for everything. They will have a new namespace. They have to take the classes here from our reference model. As you may also see here, we have BFO here as a top level. And then as you go down, we have the more domain-specific concepts like planned activity, like a study or an essay or more specific types of studies. So this is something that is built in-house here. Then internally we use Shackle as a constrained language, but as I mentioned before, and also was on one of the slides, we can then export this in a turtle, and then we use for example classifier in Protege or in Top-Rate Composer for validation. Otherwise, we also have the entire team behind here with model guidelines, principles, modeling principles, and very, very heavy reviews, long discussions, as you may imagine, if you work with ontologies around this specific groups. And the nice thing about semantic technologies is, for example, I can immediately look, for example, up in which model this concept is being used. So you see, for example, we have currently 1, 2, 3, 4, 5, 6 models that refer to study when it comes to clinical study. And all of these linkages they're built in. These are just Sparkle queries. You know, we don't have to go to fetch something. It's just the way how we have set this up. And then I could eventually also say, okay, how is this, for example, used in the study registration system here in the model? I can open this up. I can browse it. So I really have a full control of the model space. And let me just go for a second to the model browser. I'm also sliding a little bit into the demo mode here, right? Where I have here the ITO conceptual model. So see everything has a URI. We have all the version controls of the status here. And then you can visualize your model. I'm zooming in here. So then in this model, if I take something like a drug, right, or gene, these all have the same, it's an old class, but these all have the same URIs. They are all coming from the same governed entry. And this is how we achieve that we can decentralize the modeling, but the results of this domain and subdomain conceptual models will be interoperable because they will use the same classes and the same properties. So that's the short answer here to a very important question. I think this control governance, quality control, shared principles is key. So building ontologies is easy. Building good ontologies is an art and a science.
Thank you, Martin. There are 3 more questions, but maybe first, Mihai, sorry, you raised your hand already some time ago, so please.
Yeah. Okay, so hi, Martin. Thank you very much for your presentation. Very interesting. I will speak from the from the experience of OP. We're actually doing the same stuff for a number of years, and you've mentioned the idea of governance several times and control, heavy control, and it's a very important matter. So I have 2 questions on that aspect. So you said that you use the custom system for governance reason. Yeah. So what is your experience? Is imposing policy only a matter of enforcing it through? It's imposing governance only through a matter of enforcing it through the system, or you also can you used policies, let's say, that are respected by everyone. And the second one, it's about the publication process, how it is organized. You have a lot of data, a lot of things that are happening around there. Is there some kind of, I don't know, publication schedule, or it's just live things that are happening around? Everybody's doing what they think so.
Two very good questions. So to your first question, I think enforcing is always say the ultima ratio, as you would say. All these things like governance and everything have a very, very bad connotation. And I can tell you with scientists it's even worse, because scientists, they are free people, they want to do, you shouldn't constrain them. So I think we were pretty successful in convincing people. And convincing people works with, as I've also shown on this slide, with the data harmonization service, is showing them how it works and showing the results. So we are here to help you. We are not here to disturb you, to slow you down, to disrupt you, to be a pain point. And this works very, very nicely. So we really are recommended from people who have worked with us to new groups. They write us an email, hey, we have cool stuff here, we want to work with it. And then people come on board. The governance for the actual applications is something that we can also handle in a very, very flexible way, because it depends also, for example, some teams, they have subject matter experts, some other teams don't. So they outsource everything to us. We say, fantastic, we do it for you. Other people have subject matter experts, so we collaborate with them. But key here, I think, is everything is transparent. That's one point. And the other point is we never try to push back people, just say, okay, we own everything, we are ruling the world. It's a collaboration of equal people. So you sit in the business, you know about scientific correctness. We are coming more from the terminology, the ontology part. We know about formal correctness. Let's work together and try to get the best results. And I mean, also this what I've mentioned before. So the consumers, we have currently this 103 productive consumers, they really get one-to-one what they want. So it's fully customized. I just had a project started, it's under development. It started 2 weeks ago. Someone said, we have a huge problem. We have data from the master data management system and from clinical trials. When we search our database, we sometimes have a recall of 3% because we don't have hierarchies, we don't have synonyms, stuff like this. Fantastic. We have already everything integrated for you. And then we start a project with them. They get their own partition, right? In this case, it's a study information library. And they just need one terminology on indication. And they want to organize this in a hierarchy like eye disease. And they get exactly, just to show this to you here, statistics. It takes a sec to calculate. They have 560 concepts that they have used from the indication space, but the overall indication master has ways more concepts. We have 5,500. So they only get what they need. We can change the labels locally as long as they are valid labels. We can arrange hierarchies locally. And in other application contexts, they tell us, we need not only one terminology, we need, let me just take one of the productive ones here. This is, for example, a cell line registry, RNCB. They need a small terminology for biosafety levels. Then they need also something on gender. But more importantly, they, for example, have species terminologies. Here, for example, they take different kinds. You can also have the Latin name, whatever you want. So they're really getting one-to-one what they need, and they fully buy into this. And last but not least, I think what is equally important is what I mentioned before. When the systems are productive, we don't leave them alone. So we really have a support where we do so-called data sprints, with kind of a Scrum-like approach, right? where we work with the people on any kind of problem related to the data, related to definitions, to new identifiers, neoplasm organization, all the scientific domains that you can imagine. So it's really not only about the technology, but building this partnership, building this trust, and then people really buy into this. I think that's very important. So try to go the enlightened way. So Aufklärung, how say it's enlightenment, right, in English? Not, I think forcing them would only be the ultima ratio. And then, of course, everything that we have is transparent. I'm giving here a little bit a lengthy answer, but maybe let me just show this last element here. We have our business rules that we have for governance. They are also published in a wiki, and people can take a look. And we work with them on these rules, and they can be about, say, specific information types, like I know this one here, like organizations. And here, these are, for example, the business rules we have for organizations when they are mapping in mergers, acquisitions, joint ventures. What do we do with the life cycle, with the concept and everything? Yeah, so I think overall we get quite a good traction in the business. And have I answered to your second question?
No, that one is about the publication.
Yeah, very good. I can show it to you. As you see here also from the dashboard, what we need to support is incremental publication. So we cannot have long publication. Someone says, okay, I'm working on this project. I need this concept today. And this is why we have incremental publishing. So every application terminology has a publication date, and I can just, by clicking on the right mouse, when I did some changes which are approved, I can just publish it, and then they get the increment. Can be 2-3 months, can be a day, can be 2 hours. All of this depends on the business, but all of this is transparent, and we have all the previous version in the MongoDB. So at every point in time, we can step back, and we have the full audit trail, the changes we have applied. So transparency is also key, but we definitely have to support incremental publishing to be responsive to business needs.
Thank you.
Thank you, Martin. We have 5 other questions, and we need to speed up a bit, so I will go through them quickly. The first question from Willem, I think you already answered for a big part, is the dedicated team to support the governance and the reference data services you have, and the size and composition. If you could say something more. And you already said that you have 7 persons in your team.
So the first point is that most of us, we are multitaskers. So I'm the product owner of this. I'm involved in the modeling. I'm involved in the in the technical features, but I'm also involved in content. I also own some of these projects. So we have say 6 people who are both terminology, ontology experts, also know about semantic technologies. Some of them having more a content-oriented profile. Some of them having more a technical profile. Then we have also external support. So we have a CRO helping us sitting in India. That this gives us for the bulk tasks. There we have 6 FTE. We also have more premium consultants that help us a little bit more on specific tasks. And then we have 2 semantic programmers helping us on the infrastructure. Overall, I have to say this is very tight. As you can see from the number of tasks. And last but not least, we also spend a lot of time on communication. But yeah, so we are 7 people in the core team, plus 2 consultants in the technical part, plus 8 resources helping us on data curation, terminology curation.
Okay, thank you very much. There is a question from Abdel on the point that usually we forget about APIs and services when we talk about fairness. How are APIs fair? Is improving things for you in matter of automation and interoperability?
Absolutely. Yeah, I think that as I've shown, so fair APIs means that the APIs, they are also going back to this models that we're having here. When I send an indication, it uses the URI from the terminology. When I have a metadata element, it uses the URI from the metadata elements, like for country. And this is then directly machine readable and actionable on the consuming side. So indeed, we are achieving here significant gains in productivity for integration, as I've also shown with the Dataset Portal. The prices, you spend more time at the beginning, but I think it's also fair to say that this is early days. So we still, of course, our API here is using these JSON LD endpoints, but we're still spreading the word, you know, and we are hoping that we will have more and more JSON LD APIs really also transporting the semantic. So the expectations are high when it comes to scalability. Also, fair at scale, I think we are still at an early stage, hoping it will take off.
Thank you. Then there's a question of Xeni. You mentioned, just a second, yeah. You mentioned DCAT for the catalog objects. Are you using other standard schemas, ontologies for describing your data sets, also for the catalog of your semantic assets, perhaps?
Absolutely. I mean, DCAT is the core, of course, as you would guess. But when you look into the models here, I can just access it here. There's of course ways more other namespaces coming from FOV, Dublin Core, Provenance Ontology, and others. So SCOSS as well. So for the model of itself, of course, DCAT is core, but for managing everything in the Dataset Portal, we have ways more properties and stuff that we have defined here also with JSON LD snippets. So we really try to apply the FAIR principles to ourselves, say, okay, don't craft new resources when you have community vocabularies.
Okay, thanks. And there is a question from Marco from Technical Curiosity. How many triples Roche knowledge graph contains?
So the reference service that we maintains, so this is just about the reference data. We don't have too many. I think we're currently around 30 million, right? But then when we instantiate the knowledge graph, like for the models, as I've shown for I2O, or also the competitor information access platform, we typically for these domains have something between several 100 million up to 1 or 2 billion. But again, the idea is not to build one huge knowledge graph, but rather have domain-specific ones. Also, in terms of scalability or scale, I think also the knowledge graph topic is something that we are in early phases, but we are spreading out more and more and want to build a larger set of knowledge graphs. And again, I wouldn't mind to build knowledge graphs with other pharma. They don't have to be owned by Roche Genentech. Could also be something that is out there in the shared space.
Okay. Final question, perhaps, from Peter. Is the FAIR architecture playbook openly available for the broader data community?
So actually, we are currently working on a version that we want to make public. So the first version was private. I'm very much pushing to make it an open document. And yeah, can you just send me an email or so, or contact me via LinkedIn once it's available publicly? I'm happy to share it. Knowing it's not the perfect document, but it's a very good one, and it would also might be interesting to take this further as a community and mature it together. But definitely, we want to go for a public version, and it's not yet there, but it will be there maybe 2 or 3 months down the road.
Okay, excellent. If I'm not mistaken, we went through all questions from the chat. There are lots of positive reactions. Martin, on your presentation, enlightening presentation. So we can only confirm it has been a pleasure of understanding and learning from you. So thank you very much once again for your presentation. I think we can close here.
Thanks for the invitation. As I said, I really like the collaboration with the publication office, and I think also you guys are doing great things.
Okay, excellent. Thank you. We will, just for information, we have our endorsed website, and we will publish the recording. We will soon stop the recording. We will publish everything on the site, also the presentation you've given, Martin. So please don't hesitate to come back to us via the functional mailbox or the Endorse Join Up platform. So thank you very much for your contributions, and especially big thank you to you, Martin, for sharing with us your ideas and presentation and all the efforts from Roche done on that work. Quite impressive. Thank you very much again.
Thanks a lot, everybody. Take care. Have a nice day.
Thank you. Bye-bye.
Bye.